So let's start. I am going to choose a random questions. Uh, yes, I'm going to do these questions first. And Halima, I have observed you send me the queries, so I will discuss those as well at the end. So I'm going to choose random questions from this PDF, and I have shared the link of a Google Drive in the WhatsApp group, so you can get the whole PDF from there as well. Okay, the isomers, citric acid and isocitric acid are intermediates in the Krebs cycle of the oxidation of glucose in living cells. Okay. Now, how many chiral centers does each acid possess? Okay. Just give me a minute, please. Okay. So if we look at citric acid, if they are asking about the chiral center, we all know it is a carbon with 4 different groups. Okay. So yes, Hoor and Tisha, your answers are correct. So this is the carbon. And if you look at these two groups, so these two are the same groups, right? So it means it have a no chiral center. And if it have a citric acid have a no chiral center, then C and D goes wrong. Is this understandable to everyone? जी ये clear है सबको? Okay, 1 minute. Yes, I'm saying that we have to figure out a chiral center, which means one having a 4 different groups. So if I look at this carbon have a 2 same groups, CH2CO2OH and CH2CO2OH. So both are the same groups, which means it's not a chiral, and that's why I marked C and D wrong. Okay. So is this understandable to everyone? Now, look at over here. We have a CH2OH, CO2OH, sorry, CH2CO2H on one side and CHOH, CO2H on the other side of this carbon. And then I have a hydrogen as one group and CO2 as another group. So this carbon is a chiral one. I'm marking a tick over here. And if you look at this carbon is also a chiral carbon. Why? Because we have a one hydrogen over here, then we have a OH over here, then we have a CO2H over here, and then we have this whole group is bonded to this carbon. So let's make this carbon as chiral as well. So we have a 2 chiral carbons or 2 chiral centers in this isocitric acid. So that's why I will mark A wrong and B as my correct answer. Is this understandable to everyone? Okay. Now, normally students have a problem in these kind of a question as a question 2. How many structural and cis-trans isomers are there for dichloropropene? Okay. So I'm going to work on using the skeletal formula. So they are saying that it's a dichloropropene, and if it's a propene, then what I will do, I will make a propene like this. Now it have a 2 chlorine as well. So if it have a 2 chlorine as well, then let's see how we will identify the number of structural isomers and the number of cis trans isomers. Okay, let me open another page. So it's C3 H4Cl2, right? Yes. We like this, and we have a double bond over here. जी ये पॉइंट क्लियर है यहाँ तक सबको? Noor, let me check which answer is correct. So there are 2 chlorines. So there is a one possibility that 1 chlorine can be bonded over here and 1 chlorine can be bonded over here. Now, let's draw another propene. And there is a possibility that both the chlorines are bonded on this carbon. And beside this, there is another possibility that that one chlorine is bonded over here and the other chlorine is bonded over here, right? And then we have another possibility that both the chlorine are bonded on the last carbon. So if we observe, these are the structural isomers. So what I did, I just made the structural isomers. ये point यहाँ तक clear है सबको? ठीक है, अब आप देखें क्या आप कोई और स्ट्रक्चरल आइसोमर बना सकते हैं? जी, can you draw any other structural isomer? So in total, we have 4 structural isomers right now. And if you want to try, you can try. I don't think that we can make any other structural isomer. Okay. No, there is no possibility to make a 2,2 dichloropropane because if you want to draw this one, see, the second carbon have a 3 bonds already. So we can put a 1 chlorine over here, but we cannot put a 2 chlorine over here. This can be wrong because in that way the carbon have a 5 bonds and that carbon must have each carbon must have a 4 bonds. So this cannot be a correct structure. So there is no possibility due to a double bond. Okay. Now, if we look which one can show cis trans, so let me recall you to for a compound to show a cis trans isomer that it must have a carbon-carbon double bond and each double bonded carbon have a 2 different groups. So if I look at this double bonded carbon, it have a 1 hydrogen and 1 chlorine. And if I look at this double bonded carbon, it have a 1 chlorine and 1 methyl group. So it means this molecule can show cis trans isomer, right? No, Iman, what about the third one? If we look on this carbon, it have a 2 same groups. So no cis trans isomer. Okay, yeah, you are right. Here, this carbon have a two same groups, so no cis trans. And here, this carbon also have a two same groups which are hydrogen, so no cis trans. So it means that four structural isomers and one is forming a cis trans as well. So it means 4 plus 1. So total number of cis trans and geometry and structural isomers will be 5. ये point clear है सबको? Okay. And just give me a minute to look on it. 1, 2. Dichloropropene. Okay. 1, 2 dichloropropene. 1, 1 dichloropropene. 2, 3, 1. Okay. But we will forget one another possibility. If you look over here, let me zoom out a little so you can easily observe all the structures. And if I draw a propene where we have one chlorine over here and one chlorine over here, right? So this can be another structural isomer. And if it is an structural isomer, if we look over on this carbon, okay, so this carbon have a two different groups and this carbon have a two different groups as well. So it means this can also show cis and trans isomer. Is this understandable? So we have a 5 structural isomers, and out of these 5, 2 are showing cis trans isomer. So which makes that in total the number of total structural and cis trans isomers are 7. So the correct answer now, we got the number 7. So it means D is our correct answer. Is this understandable to everyone? जी ये क्लियर है सबको? Yes, is this is clear to everyone? Question number 2. Yes, Hassan, what you want to repeat? Now have a look over here. And tell me where you have a doubts. So there are 5 structural isomers of dichloropropene, and out of 5, 2 are forming cis and trans. The one you have to remember, the one which shows cis and trans must have a carbon-carbon double bond, and that double bonded carbon is bonded to 2 different groups. So if there are 5 structural isomers and 2 are showing cis trans, so it means 2 more isomers, which makes it a 7 isomers. So that's why we have in total 7 isomers, which are structural and cis trans. Okay. Now, Question number 3. Which reaction is not an electrophilic addition? Okay. So if we recall, electrophilic addition is done by alkenes, right? There are two kinds of additions in our syllabus. One is electrophilic addition, and the second one is nucleophilic addition. So if you recall, electrophilic addition, alkenes do electrophilic addition, and carbonyls, which means aldehyde or ketone, do nucleophilic addition. So if you look over here, this is an alkene. Yes, Noor, your answer is correct. And a molecule is adding up into it, and we got a one compound. So here it is an electrophilic addition, not a nucleophilic addition. And they are asking which is not a which is not an electrophilic addition. Here we have another alkene which is reacting with bromine, and we are getting another addition product. So an alkene, a molecule is adding into an alkene, so it's an again electrophilic addition. So A and B are wrong. Now if you look at C, again we have an alkene which is reacting with water and forming another addition product. So it means it is also an electrophilic addition. So C goes wrong. It means we are left with the D option. So D is correct. Yes. Noor, Tisha, Shazre, Alicia. Very good. Because C, it's a CHO, which means C double bond O and H. And when there is an addition in aldehyde and we get an addition product, then that is a nucleophilic addition, not an electrophilic addition. Is this point is clear to everyone? Okay. Which of these always applies to a nucleophile? Yes. When we talk about the how to define a nucleophile, we can say nucleophile is a species having a lone pair. So any species, whether a molecule or an ion, if it have a lone pair, then it's a nucleophile. So if you see in B, yes, very good, Halima. It has a lone pair of electrons. So that is the correct statement. It attacks the double bond. That is wrong. It is a single atom, not every time. So it's wrong. It is negatively charged, not every time. So it is also wrong. So our correct answer is B. Is this clear to everyone? Okay. Now question number 5. Compound P displays cis-trans isomerism and give a red-brown precipitate with Fehling solution. So if it shows cis-trans isomer, it means it must have a carbon-carbon double bond. And if shows red-brown precipitate with a Fehling solution, so it means it have a aldehyde as well. So if you look over here, we have a aldehyde and carbon-carbon double bond, but both the one double bonded carbon have a both two same groups. So it means it is wrong because it cannot show cis-trans isomer. Here we doesn't have aldehyde, so B goes wrong as well. Is it understandable to everyone? Yes, it's a trans. So if we look at C, a double bonded carbon have a two same groups, which means it also doesn't show cis trans isomers, so C goes wrong. Here I have a double bond, and each double bonded carbon have a two different groups, and I have a aldehyde as well. Okay, so it's D. Okay, C, it have a aldehyde, right? A have a aldehyde, but due to two same groups, it cannot show cis trans isomerism. That's why A is wrong. B doesn't have aldehyde. That's why B is wrong. In C, we have again double bonded carbon have a two different groups, so it means it doesn't have it cannot show cis trans isomer, so that's why C goes wrong. And we left with the D. Each double bonded carbon have a two different groups, right? And there is an aldehyde as well. So that's why D is the correct answer. जी ये clear है सबको point? Okay. Now question number 6. In which way ethene and propane are similar? Both belongs to different homologous series, but let's see. They are both obtained by dehydration of alcohols. So if you recall, on dehydration of alcohols, we can get alkene, but we cannot get an alkane. So A is wrong. Then they are both neutral to an indicated solution. Yes, because they are neither acid nor base. So this statement looks correct. But if I will check the rest of the statement, they can be hydrogenated using a suitable catalyst. So for that, alkene can be hydrogenated and alkane cannot be hydrogenated. That makes C wrong as well. They can both undergo polymerization under suitable conditions. So if you recall, alkene can go polymerization, but alkane cannot go polymerization, and due to which I will mark B wrong as well. So B is our correct answer. जी ये clear है सबको? Okay. Now, question number 7. Bromomethane CH3Br is used as a fumigant to destroy insect pests in grain that is to be stored. It can be made by reacting methanol with hydrogen bromide. Which type of reaction is this? So it is very easy. Who can tell me the correct answer? Which type of reaction is it? When a OH of an alcohol is displaced, then see the OH is displaced. Yes, alcohol. Free radical substitution is only done in alkane when each of alcohol is displaced. Yes, Sarah. Yes, Hamna. Yes, Halima. Very good. Whenever the OH of alcohol is displaced, then it is nucleophilic substitution. So A, B, and C all goes wrong, and B is the correct answer. Yes, who? Very good. G, ये point clear है सबको? Free radical substitution always occur in alkanes when a hydrogen bonded to a carbon is displaced by a halogen. Then it is a free radical substitution. Okay. Now, prop 2-in-1-ol, an allyl alcohol, has the following structure. Okay. Which reagent will react with prop 2 in 1 all to form a product that could exist as a optical isomer. It means they are talking about the product that must have a chiral center, right? And a chiral center means one, which have four different groups. जी ये पॉइंट क्लियर है सबको? Yes, Tisha, very good. So if I react this with the bromine, so what will happen? This double bond is converted into single bond, and we get a one bromine over here, and we get a one bromine over here. And if this happen, then if you look at this carbon, so this carbon have a four different group. One side it have a hydrogen, the other side it have a CH2Br, and on the third side it have a bromine, and on the fourth side it have a CH2OH. So C, it is the correct answer. So our answer will be A. ये यहाँ तक clear है सबको? Yes, Hoor, yes, Halima, A is correct answer. Good. So, okay. And let me show you one more thing. Basically, this is the structure of an allyl alcohol. If it is a case of B, then what will happen? We are using the hydrogen. So when we're using a hydrogen, that the double bond is broken down, and we have a hydrogen on both the double bonded carbon, which means no chiral. So that's why B goes wrong. Then if you look at C, we will using a phosphorus pentachloride, and in the presence of phosphorus pentachloride, there is no reaction occur where there is a carbon-carbon double bond, and OH is displaced by Cl. So again, no chiral, a nucleophilic substitution occurs. So C goes wrong as well. And in D, when we react with the sodium, the H of the alcohol get displaced, and again no chiral. So that's why this was our reactant. Okay. Now have a look over here. Okay. Call the use of chlorofluorocarbons is used to be phased out. Fluorocarbons are often used to replace. It means only a hydrocarbon containing a fluorine. One chlorofluorocarbon which was widely used as a solvent is CCl2FCClF2, and a large stock of it remains. One process to use up the stock is to convert it into the fluorocarbons by the following route. Okay. Now, which type of reaction is step one? Okay. So first we have to identify any change, whether any atom is decreased or any atom is increased, or what will happen. So if you will write the molecular formula, what you will identify, how many carbons are there? 2. How many chlorines are there? 2. And how many chlorines are there? 3. And how many fluorines are there? 3, right? And if you look over here, again, we have 2 carbons, 3 chlorines, and 3 fluorines. So if you look at the reactant and product of the step 1, they are same, right? Their molecular formula is same. But if you look at the structural formula, what you will find that this fluorine is shifted from the first carbon to the second carbon, and this chlorine is shifted from the second carbon to the first carbon. So if we have a molecular formula same for both the reactants and products, but their structures are different. So it means a isomer is formed, and when an isomer is formed, that reaction is considered as a isomerization. So C is our correct answer. Very good, Hoor. If it is an elimination, then the number of atoms in the product must be decreased, but the molecular formula remains same. If it's a free radical substitution, then any atom, either carbon, either chlorine or fluorine must be substituted with any other element, but that doesn't happen. So it's B, also wrong. And there is a no new substitution. So, so D also goes wrong. Okay. Yes, I will try my best, Salima. Let's see. Okay. If you look at this one, step 2. Okay. So if you look at first the formula of the product of the step 2, then again I have a C2, but now I have a Cl2 and F4, right? So see, what will happen? One chlorine is substituted by one fluorine, right? So it means it is a free radical substitution. So step 2 is free radical substitution. Now, if you look at step 3, I have a 2 carbon, 2 hydrogens, and 4 fluorine. So see, the remaining 2 hydrogen chlorines are also substituted. So it is also a free radical substitution. ये point clear है सबको? कि what are step 2 and step 3? Okay. And in normally intro, we will cover almost all the topics of organic. You will observe C. जी यहाँ तक क्लियर है सबको? अगर किसी को कोई कंफ्यूजन है तो पूछ लीजिए. Okay. Question number 10. When bromine reacts with propene, so it means it's an electrophilic addition, not substitution. Alkene is there. And there is a no electrophilic substitution in AS syllabus. In an organic solvent at room temperature, what is the mechanism by which bromine attacks the propene? So it's an electrophilic addition only. So A is our correct answer. So whenever alkene reacts with a halogen, alkene reacts with a halogen halide, alkene reacts with the hydrogen, and alkene reacts with the water, then all of them are electrophilic addition. Is this clear to everyone? Okay. Now, question number 11. A new industrial preparation of ethyl ethanoate has been developed using a cheap source of ethanol. Which process is involved at some stage in this reaction sequence? So out of these 4, if any of the one you observe, so in the first stage, what you will observing that there is a removal of 2 hydrogens, yes? Because if you look at the molecular formula over here, it is C2H6O. And if you look at the molecular formula over here, it is C2H4O. So removal of 2 hydrogens. So the removal of hydrogen, if you recall, is oxidation, right? So there is no option of oxidation. Now, if you look, it is an aldehyde. So if I will make its structure, it will be like CH3 C double bond OH. ये point समझ में आ रहा है सबको? Okay. Now we have reacted with this molecule, and when you observe, we are getting this product. तो अगर आप इस प्रोडक्ट का स्ट्रक्चर बनाएं और इसको आप फर्स्ट वन से रिएक्टेंट से कंपेयर करें तो आपको बात समझ में आएगी. नो हूर CH3C, यहाँ पे ऑलरेडी H था. ठीक है, ये डबल बॉन्ड देखें ब्रेक हुआ और यहाँ पे H आके लग गया. कहां से? यहां से, ये वाला H. और रिमेनिंग जो पार्ट बचा वो यहाँ पे कनेक्ट हो गया. ये सबको समझ में आ रहा है? And here we have an aldehyde. So when aldehyde undergo addition, इट्स एडिशन, क्योंकि डबल बॉन्ड ब्रेक हुआ है और दोनों एटम्स पे जिन दोनों पे डबल बॉन्ड था उन पे एक एक ग्रुप रिएक्टेंट मॉलिक्यूल का ऐड हो गया है. तो दैट इज कॉल्ड न्यूक्लियोफिलिक एडिशन. एडिशन व्हेन अकर्स अक्रॉस द कार्बन कार्बन डबल बॉन्ड, दैट इज अ इलेक्ट्रोफिलिक एडिशन. बट व्हेन अ एडिशन अकर्स अक्रॉस द carbon oxygen double bond in either in either aldehyde or ketone, then it is a nucleophilic addition. So here a nucleophilic addition is written. It means C is our correct answer. ये clear है सबको? जी ये clear है सबको? No, no Shazre. You guys can remember this in this way, that addition across carbon carbon double bond is electrophilic addition, and addition across carbon oxygen double bond, whether aldehyde or ketone, is nucleophilic addition. So if you see here, the addition took place across carbon oxygen double bond. So that's why it's a nucleophilic addition. Now is it understandable to everyone? Okay, who can attempt this question? Warfarin is used as a rat poison, and they are asking how many chiral centers are present in the warfarin molecule. Okay, हम ना no, your answer is incorrect. No, I didn't get the correct answer, except Hassan send me the correct answer. Very good, Hassan. No, Hassan, your answer is also wrong. So, okay, let me recall you. The carbon have a 4 different groups, right? Noor, Atif, and Iman, your answers are wrong. The carbon which have a chiral center have a 4 different groups. So, if you look on these have a double bond. So these carbons cannot have a chiral center. Any carbon which have a double bond is bonded to 3 different groups, which means it is not a chiral one. ये बात clear है सबको? If a carbon have a double bond, then that carbon doesn't have a chiral center. Why? Because due to a double bond. Yes, Sarah, you are correct. Very good. Uh, so now this carbon have a 3 hydrogens, so all the atoms are same. So it is not chiral as well. If you look at this carbon have a 2 hydrogens which are same. So there is no chiral. It is not a chiral carbon as well. No, Alicia and Hassan, your answers are wrong. Still wrong. Now try to observe this carbon. This carbon have a hydrogen on one side. On the other side, this whole group. On the third side, this whole group. And on the fourth side, we have this group. So we have a 4 different groups attached to this carbon, which have 4 different groups. So there is only one chiral center in this whole molecule. So B is your correct answer. When you said Hassan B, okay, I thought you said C. Sorry. Yes, you said B. Yes, Shazre, where is you have a doubt? No, these rings are not cyclohexene. Let me tell you. See, if you have a this ring, then it's a cyclohexene. And if you have a this ring, then this ring have a is called benzene. And in benzene, you have to remember that there is a no chiral carbon because each carbon is having a pi bond. Okay, actually there is no proper naming of a cyclic molecules in our syllabus. But if you have a cyclic structure like this, for example, so every corner is a one carbon. So there are 5 carbons, so it is cyclopentane now. But if I put a double bond over here, then it is called cyclopentene. So this is how we name them. Is it clear? So each corner is actually in the skeletal form representing a one carbon. जी यहाँ तक क्लियर है सबको? Okay. Now the structure below shows isomers of C6H12. In which pair are the members cis trans isomers of each other? Yes. Yes, Shazre. Okay. So in which pair are the members of cis trans isomers of each other? Yes, who can identify the correct pair? Yes, who can identify the correct pair? Okay, Shazre, good. Iman, good. Anybody else? No, Tisha, yours is wrong. Hamna, yours is wrong. Zehra, yours correct. Halima, yours correct. Okay, so have a look. Yes, Tisha, now yours is correct. Hassan, yours is correct. If we look at this carbon, it has two same groups, which means it cannot form any cis and trans isomers. So 4 will be the wrong option. And if 4 will be the wrong structure, so C and D goes wrong. No, Alicia. No, Ratif. Okay, correct. Yes, Tuba. Yes, you are correct. Okay, if you look at Hamna, yours is correct. Sorry. Now your second option is correct. If you look at 1 and 3, so what we conclude from 1 and 3, that they are actually same structures. They are the same molecules, but they are flipped. So that's why 1 and 3 cannot be a correct one, cannot be a pairs. So that makes 3 wrong. And if 3 is wrong, then B is the correct answer. Oh, sorry, B is wrong as well. And A is the correct answer. Now, if you compare these two, both the same group on the two carbons are on the same side, makes it cis. And here the same group on the both the double bonded carbon are on the opposite side, makes it trans. Is it understandable to everyone? Okay. In which reaction is the relative molecular mass of organic product the largest? Okay. A bromoethane. What is the formula of bromoethane? C2H5Br reacts with a sodium hydroxide. Then what organic product I'm going to get? C2H5OH. Again, I have a bromoethane. When it reacts with alcoholic sodium hydroxide, here I have a aqueous sodium hydroxide. Here I have a alcoholic sodium hydroxide. Then I'm going to get C2H4, right? An alkene. So that's make me to mark B wrong, because the MR of B must be smaller than the product of A, right? And ethane plus bromine, when ethane C2H6 reacts with a bromine, then a free radical substitution occurs. So we will get C2H5Br. And the AR of Br is, if you recall, is around 80. So there is a increase in a MR by 80 as compared to ethane. So due to which I can say that this have a higher MR than the ethanol, and that's why I mark A wrong. Is this clear? Now, here I have a ethanol C2H5OH. And when I react with the PCl5, the organic product I will get will be C2H5Cl. So the increase OH is displaced by Cl. And if you compare the MR of these two, you will find its MR lower because of a chlorine, which is 35.5. So D goes wrong as well, and C is our correct answer. Very good, Hoor. We are not getting ethane. Where is ethane? Ethane is a reactant, and the formula of ethane is it's an alkane. So CnH2n plus 2 is the general formula, due to which it's C2H6, not C2H5, Hassan. C2H5 is ethyl, not ethane. जी यहाँ तक क्लियर है सबको? Alicia, have a look. They are saying in which reaction the relative molecular mass of the organic product is the largest. So you will find the, now you will find the MR of each of these, because each one have C2C. It's one is, this one is have the lowest. So that's why I marked this one initially. Now you can calculate the MR and you can easily identify which one is the correct one. Now, did you get it, Alicia? Light initiates the following reaction when alkane reacts with a chlorine, chloroalkane, and HCl form. Okay. What happens to the chlorine in this photochemical state reaction? Okay. And if you recall, chlorine reacts in the UV light forming chlorine radicals, which means a homolytic fission occur. And in A, they have mentioned a heterolytic fission. In C, they have mentioned a heterolytic fission. Yes, very good. Tisha, Noor, Hur, Abdurrahman. Very good. And whenever a homolytic fission occurs, the product formed are radicals. So D is the correct answer. Okay. Remember, heterolytic fission occurs when an alkene during an electrophilic addition, during a nucleophilic substitution, and during a nucleophilic substitution. No, when a heterolytic fission occurs, one electrophile and one nucleophile is formed. There are two products. In case of free radical substitution, both the products formed are radicals. But when a heterolytic fission occurs, the two products we obtained must be an electrophile and other one must be a nucleophile. Is it clear, Abdurrahman? See, for example, if you recall this mechanism, when a tertiary alkyl halide reacts, so the first step is the heterolytic breaking of the alkyl halide to tertiary alkyl halide to form a carbocation. So when a carbocation is formed, this one have a positive charge, and here I have a chloride which have a negative charge. So see, it's a nucleophile, right? And it's an electrophile. So whenever a heterolytic fission occurs or heterolytic breaking occurs, the two products are, one is electrophile and one is nucleophile. Okay, now look at question number 16. It's a little trickier. High energy irradiations in the stratosphere produces radicals from chlorofluoroalkanes, commonly known as CFCs. Which radical could result from the irradiation of this molecule? So if you have this molecule, which radical will form out of these four? Justisha, your answer is correct. Anyone else who can tell me the correct answer? Okay, Hamna, very good. What about the rest of the students? I want your answers. So if you look over here, we have a two carbons. Okay, Hoor, very good. Shazre, wrong. Halima, very good. What about the rest of the students? Yes, Shazre. Now your answer is correct. Yes, kindly other students do send your answers as well. So see, the radical is formed. In each case, there is no breaking of carbon-carbon bond, and there is a breaking of either carbon-hydrogen bond, carbon-fluorine bond, or carbon-chlorine bond. And if you look in the data booklet at the bond energies, you will find that carbon-chlorine bond have a lowest bond energy. So if it have a lowest bond energy, then it means this bond will be broken very easily. Yes, Tuba, correct. And if you look at the C option, here it is CHF and then the next C. So it means this bond is broken and we will get this radical. Yes, Hoor. So C is our correct answer. Is it clear to everyone? Okay. Now who can tell me the correct answer for question number 17? Which term describe the action of sodium hydroxide aqueous on bromoalkane? And if you recall, yes, Noor, very good. Yes, Hoor, very good. When aqueous sodium hydroxide reacts with a bromoalkane, we will get alcohol. So it's a nucleophilic substitution. Yes, Hamna, Tisha, and Halima, very good, correct answers. So D is the correct answer. यहाँ तक clear है सबको? अच्छा जी. I am thinking to do the continue the organic past papers tomorrow as well. And tomorrow we will start our class at uh, 10. Okay. And I will just now discuss few queries. Then we will end our class. Halima, in the first diagram, Halima shared two questions in the group. So you can easily check those questions. And Hamna, can you send your queries in the group as well? Now I will discuss those queries and then we will end our class. Okay, in the first diagram, which question you want to discuss, Halima? Question number 24 or 25? Okay, question number 25. Okay, let me see. In question number 25 that you have sent, Okay, it's a paper 1 May June 21. Okay. When an organic compound is oxidized, any oxygen atom gained by the organic molecule is considered to be from a water molecule producing hydrogen ions and 2 electrons. Any hydrogen atom lost may be considered to be lost as H positive and electron. Okay, these changes can be represented by the following two equations. Okay, so you all have the equations in your in the diagram. Okay, Shazre. Compound X is oxidized by heating and reflects with hot acidified potassium dichromate 6 for 1 hour. The half equation for the reduction reaction is shown. Under these conditions, 1 mole of potassium dichromate oxidizes 3 molecules of X. What could be X? Okay. So, if we look at the first option, that is propanol, and if propanol undergo oxidation, then what it will form? A propanoic acid. Then we have a propane one all. CH3, CH2, CH2OH. It will also convert into propanoic acid, CH3, CH2, CO2H. And then we have a propane 1,2 diol. So it is CH3, CHOH, and CH2OH. And in this case, I'm going to get a molecule having a ketone functional group and a carboxylic acid functional group. That is part C. I am drawing for each part. Then we have a part D. Here they are saying it's 1,3 diol. So what I'm going to get a molecule having a 2 carboxylic acid. जी, ये पार्ट यहाँ तक अगर किसी को कोई कंफ्यूजन है तो पहले पूछ लें, फिर आगे बात करते हैं. हीट अंडर रिफ्लक्स कंडीशंस. जी, यहाँ तक ये क्लियर है. हीट अंडर रिफ्लक्स में सब ऑक्सीडाइज होंगे और अल्कोहल ऑक्सीडाइज होता है तो कार्बोक्सिलिक एसिड या कीटोन बनाता है डिपेंडिंग ऑन द स्ट्रक्चर. एंड कीटोन ऑक्सीडाइज होता है, सॉरी, सेकेंडरी अल्कोहल ऑक्सीडाइज होता है तो कीटोन बनाता है, और प्राइमरी अल्कोहल ऑक्सीडाइज होता है तो कार्बोक्सिलिक एसिड बनाता है. एंड अगर एल्डिहाइड ऑक्सीडाइज होता है तो वो भी क्या बनाता है? कार्बोक्सिलिक एसिड बनाता है. ओके. अब यहाँ पे जो ऊपर वो इंफॉर्मेशन दे रहे हैं वो ये दे रहे हैं कि an organic compound is oxidized, any oxygen atom gained by the organic molecule is considered to be from a water molecule also producing 2 H positive and 2 electrons. ओके, तो अगर आप यहां पे देखें तो इस केस में एक ऑक्सीजन एटम गेन हुआ है। तो इसका मतलब क्या हुआ कि अगर मैं इसकी हाफ इक्वेशन बनाऊं तो जिस जो इंफॉर्मेशन वो दे रहे हैं उसके अकॉर्डिंग एक ऑक्सीजन एटम गेन होने की वजह से 2 हाइड्रोजन आइंस एंड 2 इलेक्ट्रॉन्स प्रोड्यूस होंगे। ये बात समझ में आ रही है सबको? जी, ये पॉइंट क्लियर है सबको? ओके, तो एक मिनट जरा मुझे दो। यहाँ पे डबल बॉन्ड ओ है और यहाँ पे अच्छा, अब अगर आप सेकंड केस देखें तो सेकंड केस में 2 हाइड्रोजन लॉस हो रहे हैं। अगर आप अगली स्टेटमेंट पढ़ें जो मैंने जहां पे कंप्लीट की थी कि एनी हाइड्रोजन एटम में लॉस बी कंसिडर्ड एज अ H पॉजिटिव एंड 1 इलेक्ट्रॉन। अगर कोई ऑर्गेनिक कंपाउंड से हाइड्रोजन लॉस होगा तो वो H पॉजिटिव और इलेक्ट्रॉन के साथ लॉस होगा। तो यहाँ पे क्या हुआ है कि एक ऑक्सीजन ऐड हुआ है, उस ऑक्सीजन के ऐड होने की वजह से 2H पॉजिटिव एंड 2 इलेक्ट्रॉन्स हैं, बट साथ 2 हाइड्रोजन भी लॉस हुए हैं जिसकी वजह से 2H पॉजिटिव और 2 इलेक्ट्रॉन्स होंगे। तो इन टोटल सेकंड इक्वेशन में 4 इलेक्ट्रॉन्स और 4 हाइड्रोजन आइंस होंगे। क्यों? क्योंकि 2 हाइड्रोजन लॉस हुए हैं और एक ऑक्सीजन गेन हुआ है। ये वाला पॉइंट क्लियर है सबको? जी। और अगर आप थर्ड केस देखें तो थर्ड केस में अगेन हमारे पास 2 हाइड्रोजन लॉस हो रहे हैं, बल्कि 4 हाइड्रोजन लॉस हो रहे हैं। और कितने ऑक्सीजन ऐड हो रहे हैं? एक ऑक्सीजन ऐड हो रहा है। तो इसका मतलब है कि 6H पॉजिटिव एंड 6 इलेक्ट्रॉन्स यहां पे आएंगे। ये बात समझ में आ रही है सबको? जी, किसी को कंफ्यूजन है इसमें तो पूछ लीजिए, उस क्वेश्चन को दोबारा पढ़िए। जो ऊपर 2 हाफ इक्वेशंस दी हैं उससे पहले उन्होंने बताया है, ये इंफॉर्मेशन प्रोवाइड की है कि अगर मॉलिक्यूल में एक ऑक्सीजन ऐड होगा तो उस एक ऑक्सीजन ऐड होने के साथ साथ 2 हाइड्रोजन आइंस और 2 इलेक्ट्रॉन्स बनेंगे। और अगर मॉलिक्यूल से एक हाइड्रोजन रिमूव होगा तो उस हाइड्रोजन आयन के साथ साथ इलेक्ट्रॉन भी रिलीज होगा। तो उसकी बेसिस पे हम यहाँ पे इलेक्ट्रॉन्स और हाइड्रोजन्स लगा रहे हैं। अब अगर आप इसको कंपेयर करें तो इस केस में यहां से एक हाइड्रोजन लॉस हुआ है और यहां से एक हाइड्रोजन लॉस हुआ है और यहाँ पे 2 ऑक्सीजन्स गेन हुए हैं। जी, ये पॉइंट यहां तक क्लियर है? तो अगर 2 हाइड्रोजन लॉस हुए हैं तो 2 हाइड्रोजन आइंस, और 2 ऑक्सीजन गेन हुए हैं तो 4 हाइड्रोजन आइंस। तो अगेन आपके पास 6 हाइड्रोजन आइंस और 6 इलेक्ट्रॉन्स यहाँ पे फॉर्म होंगे। ये वाला पार्ट सबको क्लियर हो गया? अब उसके बाद उन्होंने पूछा है कि एक्स वो मॉलिक्यूल है जिस मॉलिक्यूल के 3 मोल्स 1 मोल डाइक्रोमेट से रिएक्ट कर रहे हैं। तो 1 मोल अगर आप डाइक्रोमेट देखें तो वो कितने इलेक्ट्रॉन्स गेन कर रहा है? 6 इलेक्ट्रॉन्स गेन कर रहा है। ठीक है, 6 इलेक्ट्रॉन्स गेन कर रहा है। तो इसका मतलब जिसके पी मोल से 6 इलेक्ट्रॉन्स लूज हों, तो ये हमारे पास फर्स्ट इक्वेशन बनेगी। अगर मैं फर्स्ट इक्वेशन को टाइम्स 3 कर दूंगा तो ये 3 मोल्स हो जाएंगे और यहाँ पे मुझे 6 इलेक्ट्रॉन्स मिल जाएंगे। अच्छा, और सेकंड 2 में 1 1 मोल ही यूज होगा सी और डी में। क्यों? क्योंकि 1 मोल मोल के जो है डाइक्रोमेट के साथ इनका 1 1 मोल रिएक्ट करेगा, क्योंकि इन दोनों में 6 इलेक्ट्रॉन्स ही लूज हो रहे हैं। तो इनके जो नंबर ऑफ इलेक्ट्रॉन्स हैं वो इक्वल हैं। अब डी में यहाँ पे 4 इलेक्ट्रॉन्स हैं और वहां पे 6 इलेक्ट्रॉन्स हैं। ठीक है, तो हमें बैलेंस करने के लिए दोनों के लिए कोएफिशिएंट यूज करना पड़ेगा। तो हमारे पास यहाँ पे 1 मोल के लिए 3 मोल्स आंसर इस केस में भी नहीं आएगा। तो इसका करेक्ट आंसर इस वजह से ए होगा। जी, ये पॉइंट क्लियर है सबको? So A will be your correct answer. Yes, is this understandable to everyone? And the question is present in the WhatsApp group, question number 25. पेपर 1 मई जून 21 का है. Okay. Now the next question is question number 33, where they are saying a gaseous hydrocarbon has a density of 2.42 gram per dm cube. It's a hydrocarbon, right? And they didn't tell us the number of carbon and hydrogen, neither whether it's an alkane or alkene. What could be the skeletal formula of this hydrocarbon? तो बेटा हमें पता है कि कोई भी अगर वो गैस है तो उसके 1 मोल कितना वॉल्यूम ऑक्युपाई करते हैं? 24 dm³ ऑक्युपाई करते हैं। तो पहला तो आपके पास क्या है? ब्यूटेन है, यानी कि C4H10। ठीक है, तो इसके MR को आप 24 से डिवाइड कर दें क्योंकि गैस है। दूसरा आपके पास साइक्लोब्यूटेन है, साइक्लोब्यूटेन का फॉर्मूला होता है C4H8। तो इसके MR को 24 से मल्टीप्लाई कर दें तो इसकी डेंसिटी आ जाएगी। और थर्ड वन है अगेन ब्यूटीन है C4H8, तो उसके MR, इन दोनों का MR तो सेम ही आएगा, 24 से डिवाइड कर दें तो सब केसेस में ग्राम पर dm³ हो जाएगा। तो या तो आपका आंसर C आएगा या फिर आपका आंसर D आएगा, क्योंकि A की डेंसिटी 1 की डेंसिटी 2 और 3 से डिफरेंट होगी, बट 2 और 3 की डेंसिटी बिल्कुल सेम होगी। तो ये आप आंसर्स निकाल लें और जिसका आंसर आ रहा होगा उसके अकॉर्डिंगली सॉल्व कर लेंगे, तीनों के MR लिख के। क्लियर है यहां तक सबको? भाई इसका MR तो होगा आई थिंक 58 और इनका होगा 56। जरा कोई मुझे जल्दी से कैलकुलेट करके बता सकता है तो बता दे। या तो आपका आंसर ए आएगा 1 ओनली, या फिर सी आएगा 2 और 3। जी 2.42 किसका आ रहा है? 1 का आ रहा है 2.42, तो इसका मतलब है कि इन दोनों के 2.42 नहीं आएंगे तो 1 ओनली, सॉरी मैं ए कह रहा था, तो इसका मतलब है करेक्ट आंसर डी है, सी या डी में से कोई एक होता। क्लियर है सबको? ओके, just give me a minute. Okay, Shazra is not there. Okay, so question number 164. Okay, question number 160. Okay, this is the another query. Ethyl ethanoate can be obtained from ethanoic acid and ethanol by the following reaction. Okay, आप सब familiar हैं इस reaction से, ठीक है ना? 30 gram of ethanol and ethanoic acid are heated under reflux together, and 22 gram of ethyl ethanoate are obtained. What is the yield of ester? Okay, देखें किसी भी एक से वर्क कर लें, अगर मैं इथेनॉल से वर्क करूं तो इथेनॉल का एमआर क्या आएगा? 1 मोल ही है ना, तो मुझे उसका एमआर चाहिए। सो 2 कार्बन्स मेक इट 12, oh sorry 24, 24 and 1 oxygen make it 16, 24 plus 16 40 and 6 hydrogen, so it's 46। ये क्लियर है सबको? अब मैं अगर इसका भी 1 मोल है ईस्टर का, तो मैं इसका भी अगर कैलकुलेट करूं एमआर, तो क्या होगा? 4 कार्बन हैं, सो 12 4 48, 2 हाइड्रोजन हैं which is 32, so 48 plus 32 makes it 80, and then we have our 8 hydrogens, so 88। तो हमें ये पता चल रहा है कि 46 ग्राम से 88 ग्राम्स प्रोड्यूस होगा। और अगर मैं 30 ग्राम्स इथेनॉल ले लूं, तो ये कितना प्रोड्यूस होना चाहिए? अच्छा एक मिनट, 30 ग्राम्स इथेनॉइक एसिड भी दिया हुआ है, अगर मैं इसका एमआर निकालूं तो 24 प्लस 630, 24, 28, 28 and 32, so it is 50। बेसिकली ये लिमिटिंग रिएक्टेंट रिलेटेड क्वेश्चन है। एक काम करें पहले, मुझे अच्छा इसका एमआर जरा कंफर्म करें। आई थिंक इट्स एमआर इज 60 ऑफ इथेनोइक एसिड, राइट? सो if I use a 30 gram methanol, then how much mass of X is needed? Can anybody tell me the answer? What will be the mass of ethanoic acid is needed? यहाँ पे X की वैल्यू क्या आ रही है, कोई मुझे कंफर्म कर दे जल्दी से। It is 57.4। Okay, so this is indicating no. How? Let me check. 30 times 60 divided by 46. Isn't it 39.13? It's 39.13. So it means, see over here, for 30 grams of ethanol, we need 39.14 gram of ethanoic acid. But in actual, we have a 30 gram of ethanoic acid, which means that it is in excess, and ethanoic acid is a limiting reactant। ये बात सबको समझ में आ गई है कि इथानोइक एसिड क्या है? लिमिटिंग रिएक्टेंट है। तो इसका मतलब है हम एसिड और ईस्टर का रेशियो लेंगे, और 60 ग्राम्स अकॉर्डिंग टू द इक्वेशन 60 ग्राम्स ईस्टर से 88 एसिड से 88 ग्राम ईस्टर फॉर्म हो रहा है। तो अगर 30 ग्राम्स से कितना प्रोड्यूस होगा? व्हाट डू यू मीन बाय रिवर्स हमना? ओके, सो थिंक, अगर मैं 30 ग्राम्स को कंप्लीट यूज कर लेता हूं तो उसके लिए मुझे तो इथानोइक एसिड 39.14 चाहिए, बट इथानोइक एसिड मेरे पास एक्चुअली कितना प्रेजेंट है? 30। तो जिसका मतलब है कि इथानॉल का 30 ग्राम्स जो गिवन है उसमें से सिर्फ उतना मास रिएक्ट करेगा जो 30 से हो सकता है, अदरवाइज नहीं करेगा। जो रिमेनिंग है वो नहीं करेगा। ये पॉइंट क्लियर हुआ हम ना? तो वो आंसर रॉन्ग हो जाएगा क्योंकि इथानॉल की जो मास यूज किया है वो कंप्लीटली कंज्यूम नहीं हो रहा, उसमें से कुछ ना कुछ बच रहा है। यस हलीमा, तो इन दिस केस आई विल गेट द वैल्यू ऑफ एक्स 44। तो एक्चुअली कितना बनना चाहिए था? 88 बना कितना? 44। तो परसेंटेज यील्ड क्या आएगी? 50। सो सी इज माई करेक्ट आंसर। जी क्लियर है ये सबको? Yes, Hamna, it's your query. So is it clear to you as well? Okay, see. According to the equation, the mole ratio of both the reactants are 1:1. Is this understandable to everyone? The mole ratio of both the reactants are 1:1. So if we uses their MR, so what we can identify that 46 grams of ethanol will react with 60 grams of ethanoic acid, right? And the given mass of ethanol is 30 grams and the given mass of ethanoic acid is also a 30 gram. So the thing is that these two masses are not in the exact ratio, because when we calculated the value, what we found that if there is a 30 gram of ethanol, then to react completely the 30 gram of ethanol, we need 39.14 gram of ethanoic acid. But we don't have a 39.14 gram of ethanoic acid. Instead, we have only 30 grams of ethanoic acid. Is this understandable to everyone? And if ethanoic acid is 30 grams, then it clearly indicates that all of the ethanol is not consumed, because to consume the whole 30 gram of ethanol, we must need 39.14 gram of ethanoic acid. So it is indicating that if the mass of ethanoic acid used is 30 gram, then there must be some mass of ethanol which left unreacted. Is this clear? Yes, is this point is understandable to everyone? This mass is needed, but yes, we can do that. We can do that, and that way you can also again get a same answer. The percentage will be 50. But in actual, only 30 gram is provided. And on the basis of that, what we can conclude that it is an excess reagent. And if it's an excess reagent, so we cannot use the 30 gram of that excess reagent for the further calculation. That's why I use the and take the ratio of ester with the acid. Now, is it understandable? Okay, so I'm ending my class over here. And tomorrow, inshallah, we will start at 10 o'clock. Okay, take care, everyone. And tomorrow we will continue doing further organic papers only. Okay. Okay, take care, everyone. Allah Hafiz.